June 12, 1943, Baltic Sea Test Range, near Königsberg. Engineer Karl Heinrich von Blücher knelt on the weathered deck of the HSWMS Bavarian, a converted German cargo ship repurposed for secret weapons testing. His gloved fingers adjusted a brass radio antenna, twisting it in 5-degree increments to lock onto the frequency of the vehicle 30 meters below. Beneath the choppy gray waves, a Panzerkampfwagen 4 medium tank, its hull sealed with rubber gaskets, a steel snorkel rising from its turret, crept along the sandy seabed. Von Blücher's ear pressed to a headphone set, listening for the steady beat that signaled the tank was moving at 3 kilometers per hour, its 4-man crew alive and functioning. He checked his pocket watch. 10 a.m. The tank had been underwater for 45 minutes, longer than any previous test. At 10:15 a.m., the signal shifted. 3 short beeps, then a long one. The crew was surfacing. Minutes later, the tank's turret broke the water surface, followed by its hull, water streaming off its armor plates. The snorkel, now lowered, folded neatly against the turret. Von Blücher stood, brushing salt spray from his uniform, and nodded to his assistant, who recorded the data in a leather-bound logbook. This was the Schwimmpanzer IV swimming tank, Germany's most ambitious attempt to build an underwater armored vehicle capable of crossing rivers and coastal inlets undetected. It was a marvel of mid-20th century engineering, a tank that could transition from land to sea, bypass enemy defenses, and strike behind enemy lines. But it would never see combat. Plagued by material shortages, technical flaws, and the shifting tides of war, the Schwimmpanzer IV will become a forgotten relic, proof that even the most brilliant ideas can fail when technology cannot keep pace with ambition. The origins of the underwater tank trace to Germany's earliest World War II campaigns. In 1939, the Wehrmacht's blitzkrieg had overwhelmed Poland, but river crossings had proven costly. At the Vistula River, German tanks had waited 36 hours for engineers to build bridges, exposing them to Polish artillery fire. In 1940, during the Battle of France, the Meuse River had delayed panzer divisions for 48 hours, time that nearly cost Germany the campaign. Adolf Hitler, furious at these delays, demanded a solution in a July 1940 meeting with the Heereswaffen, Army Weapons Office. "I want a tank that can swim. No more waiting for bridges." The task fell to Krupp, Germany's leading tank manufacturer, and to Karl Heinrich von Blücher, a 42-year-old engineer with a background in amphibious vehicle design. Von Blücher had previously built small amphibious scout cars for the Army. Now, he was tasked with scaling that technology to a 25-ton tank. Von Blücher's team began with a standard Panzerkampfwagen 4 OSF F, a medium tank that had proven reliable in combat. The OSF F weighed 25 tons, featured 30 to 50 millimeters armor plating, and was armed with a 75 millimeters KWK 37 short barrel gun and 2 7.92 millimeters MG 34 machine guns. The first and most critical challenge was waterproofing. A tank's hull is not a sealed container. Engine vents, hatches, and electrical connections all let in water. The team addressed each vulnerability. Hatches, every hatch, commanders, drivers, loaders, was fitted with double-layered rubber gaskets, 2 centimeters thick, made from natural rubber imported from Southeast Asia, held in place by metal clamps that could be tightened by hand. A secondary seal of beeswax was applied around the edges to block small leaks. Engine vents. The tank's rear engine vents were modified with one-way valves, spring-loaded flaps that opened to let hot air escape on land, but closed tight underwater to prevent flooding. A small air filter was added to each valve to keep sediment out. Electrical systems. All wiring was coated in a thick layer of paraffin wax, and electrical connectors were sealed with rubber boots filled with petroleum jelly. The tank's battery was moved to a waterproof compartment in the turret, where it was shielded by a steel plate. Snorkel. A 1.5-meter tall steel snorkel was welded to the turret's rear. It featured a float valve at the top. If waves covered the snorkel, the valve closed to keep water out, and a flexible hose that ran to the engine's air intake and the crew compartment. The snorkel could be raised or lowered manually by the commander using a hand crank. The second challenge was underwater propulsion. On land, the Panzerfor used its metal tracks to reach 40 kilometers per hour, but underwater, tracks would stir up sand and mud, slowing the tank and reducing visibility. Von Blücher's team added 2 electric propellers, each 60 centimeters in diameter, made from bronze to resist corrosion, mounted on the rear hull, one on each side of the exhaust. The propellers were powered by a 20-horsepower electric motor, which drew power from a separate bank of 6 lead-acid batteries. The main 300-horsepower Maybach HL1 20TRM gasoline engine was shut down underwater to avoid flooding. The motor was connected to a simple gearbox, allowing the driver to switch between forward and reverse. Underwater, the tank could move at 3 kilometers per hour, slow, but enough to cross a 1-kilometer wide river in 20 minutes. For steering, the driver used the tank's existing track brakes. Applying pressure to one brake would slow the track, turning the tank left or right, just as on land. The third challenge was crew survival. A sealed tank underwater is a death trap without proper life support. The team installed 3 critical systems. Oxygen supply. A 50-liter compressed oxygen tank was mounted in the turret, connected to 4 face masks, one for each crew member. The tank held enough oxygen for 60 minutes of breathing, more than enough for most river crossings. Carbon dioxide scrubber. A small canister of calcium hydroxide was placed near the loader's position. Exhaled air was drawn to the canister, where the calcium hydroxide absorbed CO2, preventing the crew from suffocating. Emergency gear. Each crew member wore a waterproof rubber suit and a life jacket inflated with carbon dioxide. The tank carried 2 emergency breathing apparatus, small oxygen cylinders with 10 minutes of air, for use if the main system failed. To navigate underwater, the driver used a periscope modified with a waterproof glass lens, while the commander monitored a depth gauge marked in meters and a compass. The tank also carried a short-range radio, allowing the crew to communicate with surface support teams, critical for coordinating crossings and calling for help if the tank became stuck. If you found this interesting, give it a thumbs up to show your support. Drop a wonderful in the comments to let me know you're still with me. Stick around till the end, because I'll reveal 3 mind-blowing facts you won't want to miss. Haven't followed yet? Hit that follow button so you won't miss our next deep dive. Trust me, the best is yet to come. The first test of the Schwimmpanzer IV prototype took place on March 5, 1942, at the Oder River near Berlin. The crew, Lieutenant Erich Müller, commander, a veteran of the French campaign, Feldwebel Hans Schmidt, driver, who had trained on amphibious vehicles, Gefreiter Karl Weber, gunner, and Oberstfreiter Heinz Bauer, loader, climbed into the tank, sealed the hatches, and drove into the river. The tank submerged to 5 meters, its snorkel rising above the water like a steel periscope. For 20 minutes, it crept along the riverbed, moving 500 meters upstream. When it surfaced, the crew reported no major leaks, but the electric motor had overheated. Its air-cooled system was not designed for the cold damp underwater environment. Von Blücher's team added a water-cooled jacket to the motor, circulating river water around the engine to keep it at 40 degrees Celsius. The next test on April 10th lasted 35 minutes without issues, and the motor stayed within safe temperature limits. By June 1942, the team had built 5 prototypes, each with incremental improvements. They reinforced the hull with extra 10mm steel plates around the snorkel and propeller mounts to withstand water pressure up to 10 meters deep, enough for most European rivers and coastal inlets. They added a simple sonar system, borrowed from German U-boats, to detect obstacles on the seabed. The sonar displayed echoes on a small screen in the commander's position, warning of rocks or deep mud. They even modified the turret to fire the MG-34 machine guns underwater, though the 75mm main gun was too powerful. Firing it underwater would have flooded the breach. The Army Weapons Office was impressed. In July 1942, they placed an order for 100 Schwimmpanzer IVs, with the first production model scheduled for delivery in early 1943. The tanks would be assigned to a new unit, Panzerabteilung 100, Tank Battalion 100, trained specifically for underwater operations. Production of the Schwimmpanzer IV began at Krupp's Essen factory in September 1942, but it was immediately hampered by shortages. Germany's steel production was focused on building standard Panzer IVs and Tiger I heavy tanks for the Eastern Front, so the Schwimmpanzer IV had to use thinner armor, 30mm on the front hull, down from 50mm on the standard OSF and 20mm on the sides. Rubber for gaskets became scarce after Allied blockades cut off imports from Southeast Asia. The team was forced to switch to synthetic rubber made from coal tar, a material that was stiffer, less flexible, and prone to cracking in cold water. Electrical components were also in short supply. Some prototypes used wiring salvaged from damaged aircraft, which was not designed for underwater use. Building each Schwimmpanzer IV required 2,500 hours of labor, 500 more than a standard Panzer IV. Due to the intricate waterproofing, workers spent 8 hours sealing each hatch, applying rubber gaskets and wax with precision. The electric motor and battery bank were assembled in a separate cleanroom to avoid dust contaminating the waterproof seals, before being lifted into the rear hull with a 50-ton crane. Each tank was tested in a 15-meter deep water tank at the factory, submerged for 30 minutes, with pressure gauges monitoring for leaks. If a leak was detected, the tank was drained, the faulty seal repaired, and the test repeated. By December 1942, only 20 Schwimmpanzer IVs had rolled off production line, half the planned number. The Baltic Sea test range, 50 kilometers from Königsberg, became the Schwimmpanzer IVs proving ground in January 1943. The cold, brackish water, 2 to 4 degrees Celsius in winter, revealed new flaws. The synthetic rubber gaskets contracted in the cold, creating small leaks around the hatches, enough to drip water into the crew compartment, though not enough to flood it. The electric motor's battery life was shorter than expected, 60 minutes of underwater use, instead of the planned 90, because the cold slowed the chemical reaction in the lead acid cells. The sonar system, designed for deep-sea U-boats, was too sensitive for shallow coastal waters. It picked up every rock, sandbar, and even schools of fish, overwhelming the commander with false alarms. Worst of all was the tank's buoyancy. The Schwimmpanzer IV weighed 27 tons with its waterproofing and batteries, 2 tons more than the standard model. When surfacing in rough seas, the extra weight made it slow to rise. Waves would push the tank back down, and the snorkel would sometimes clog with seaweed or sediment. On February 28, 1943, A storm hit during a test. The tank, commanded by Lieutenant Muller, became trapped 8 meters below the surface when its snorkel clogged. The crew activated the emergency oxygen supply and used a hand pump to bail out water, but they were running out of air when the storm subsided and the tank finally surfaced. Muller later wrote in his report, "The cold was unbearable. Water dripped from the ceiling onto our heads, and we thought we would drown." Von Blücher's team addressed each issue with urgent modifications. They added small electric heaters to the hatch gaskets, powered by the battery bank. To keep the rubber flexible in cold water, they increased the battery bank from 6 to 8 cells, extending underwater life to 80 minutes. They recalibrated the sonar to ignore objects smaller than 1 meter, reducing false alarms. To improve buoyancy, they added 2 20-liter compressed air tanks to the hull. When activated by the driver, the tanks filled with air, lifting the tank to the surface in 2 to 3 minutes. By May 1943, the Schwimmpanzer was performing reliably. It could cross a 1-kilometer-wide river in 25 minutes, stay underwater for 80 minutes, and fires machine guns to clear enemy infantry from the shore. The Army Weapons Office ordered 50 more units, with plans to deploy Panzerabteilung 100 to the Eastern Front in August 1943, where they would lead the Wehrmacht's crossing of the Dnieper River. Panzerabteilung 100 was formed in June 1943, based at a training camp near Poznan, Poland. The unit's 400 soldiers, selected for their experience with tanks and swimming, underwent 6 weeks of specialized training. They practiced underwater navigation in the Varta River, learning to use a periscope and sonar to avoid obstacles. They drilled on emergency procedures, sealing leaks with rubber patches, switching to backup oxygen supply, and escaping through the hatch if the tank flooded. They even practiced coordinating with surface teams, engineers and rubber boats who would mark the crossing route with buoys and rescue the crew if the tank became stuck. By July 1943, the unit was ready, but the Schwimmpanzer IVs were not. Only 30 tanks had been completed, and half of those had faulty synthetic rubber gaskets that needed replacement. Then the war intervened. On July 5, 1943, the Wehrmacht launched Operation Citadel. The Battle of Kursk, the largest tank battle in history. The offensive was a disaster. Germany lost 2,900 tanks, 1,600 aircraft, and 100,000 soldiers. The Eastern Front collapsed, and the Soviet Union began pushing west. The Dnieper crossing was canceled. Instead, the Schwimmpanzer IVs were ordered to defend the Vistula River, where Soviet forces were advancing. But the tanks were not ready for combat. During a pre-deployment test on August 10, 1943, 3 Schwimmpanzer IVs developed leaks in their engine compartments. Synthetic rubber gaskets had cracked after repeated use. Von Blücher begged the Army Weapons Office for more time to repair the tanks, but the order came down. Deploy immediately or the tanks will be scrapped for parts. The Schwimmpanzer IV's only combat deployment never happened. On August 15, 1943, Soviet forces crossed the Vistula River before Panzerabteilung 100 could reach the front. The unit was diverted to defend Warsaw, but the Schwimmpanzer IVs were useless in urban combat. Their snorkel and propellers were damaged by debris, and their thin armor made them vulnerable to Soviet anti-tank rifles. The tanks were parked in a warehouse on the outskirts of the city, where they sat unused for a month. In September 1943, the Army Weapons Office canceled the project. The official reason: the Schwimmpanzer IV is no longer tactically necessary, given the current situation on the Eastern Front. The final test of the Schwimmpanzer IV took place on September 8, 1943, near Gdynia, Poland. 3 tanks were ordered to cross the Vistula River underwater, simulating a defensive mission to destroy a Soviet bridgehead. The first tank, commanded by Lieutenant Muller, submerged at 6 a.m. and surfaced 25 minutes later, 1 kilometer upstream, without issues. The second tank, commanded by Feldwebel Schmidt, developed a small leak in the loader's hatch 500 meters into the crossing. The crew used a rubber patch to seal it and surface safely. The third tank, commanded by Gefreiter Weber, never emerged. Its radio signal cut off 700 meters from shore, and a search team later found it on the seabed. Its hull crushed by water pressure. An unknown fault in the steel plating had given way under the weight of the water. The crew of 4, Weber, his loader, driver, and commander, drowned. It was the Schwimmpanzer IV's only fatal accident, but confirmed the project's flaws. On September 15, 1943, the Heereswaffen formally terminated the Unterwasserpanzer program. Most of the remaining Schwimmpanzer IVs were scrapped for steel in late 1943. Their metal used to repair standard Panzer IVs on the Eastern Front. A handful were sent to the Panzer Museum in Munster, but they were destroyed during British bombing raids in October 1944. Von Blücher, devastated by the project's failure, requested a transfer to the front lines. He was assigned to a panzer division fighting in East Prussia and was killed in action on January 21, 1945, during the Soviet siege of Königsberg. The members of Panzerabteilung 100 were reassigned to other units. Most fought in the Battle of Berlin in April 1945, and few survived the war. Only 1 Schwimmpanzer for escape destruction, a prototype, serial number 101, hidden in a Krupp warehouse in Essen, where it had been stored for repairs. In April 1945, American troops captured the warehouse and found the tank, its snorkel still attached, its hull covered in dust. The tank was shipped to the United States in June 1945 as part of Operation Lusty, a program to collect and study German weapons technology, and arrive at the Aberdeen Proving Ground in Maryland for testing. American engineers at Aberdeen were surprised by the Schwimmpanzer IV's sophistication. They noted that the waterproofing system was ingenious in its simplicity, with the rubber gaskets and wax seals providing effective protection against water intrusion. The electric propeller system was surprisingly efficient, though under power for combat speeds. But they also identified critical flaws. The synthetic rubber gaskets deteriorated rapidly after repeated use. The battery life was insufficient for extended missions, and the thin armor would not withstand anti-tank fire from close range. In their final report, issued in December 1945, the U.S. Army concluded that an underwater tank was technically feasible but tactically impractical. Bridges and amphibious vehicles like the DUKW, a 2.5-ton truck with floats, were cheaper, more reliable, and easier to maintain. The prototype was eventually donated to the Smithsonian Institution in 1950, where it was restored and put on display. The Schwimmpanzer IV's technical legacy, though subtle, influenced post-war military design. Its waterproofing techniques, rubber gaskets, one-way valves, and wax-coated wiring, were adapted for use in the U.S. Army's M113 armored personnel carrier, which entered service in 1960, and could cross rivers underwater using a snorkel. The electric propeller system inspired the design of underwater robots used in marine research, including the first remotely operated vehicles, ROVs, developed in the 1950s. Even the idea of a swimming tank was revived by the Soviet Union in the 1960s with the PT-76, an amphibious light tank that could swim at 10 kilometers per hour faster than the Schwimmpanzer IV, and saw combat in Vietnam and the Middle East. The PT-76 used many of the same principles: a sealed hull, a snorkel for air, and propellers for underwater propulsion. But the Schwimmpanzer IV's greatest legacy is as a cautionary tale about technological ambition. It was a weapon ahead of its time, built with materials and components that could not meet its demands. The synthetic rubber of 1943 was not durable enough for repeated underwater use. Modern synthetic rubbers, developed in the 1950s, would have solved the gasket problem. The electric motors of 1943 lacked the power to drive the tank at combat speeds. Post-war electric motors, with better insulation and more efficient batteries, would have made underwater travel faster and more reliable. Even the steel plating, limited by World War II-era manufacturing techniques, could not withstand deep water pressure. Modern high-strength steel would have prevented the hull failure that killed Weber's crew. Today, the Schwimmpanzer IV prototype sits in the Smithsonian's National Museum of American History, in a gallery dedicated to World War II technology. Its hull is dented from its Baltic Sea tests, its snorkel rusted but intact, its rubber gaskets hardened with age. A plaque next to it reads, Krupp Schwimmpanzer IV 1943. Germany's World War II underwater tank, too advanced for its time. Visitors often pause to study it, wondering how a tank could ever swim. Some ask why it failed. Others marvel at the ingenuity of its design. It is a reminder that innovation is not just about ideas. It is about having the tools, materials, and time to turn those ideas into reality. In the archives of Krupp's Essen factory, stored in climate-controlled vaults, there are still drawings of von Blücher's unbuilt designs. Sketches of the Schwimmpanzer VI, a larger underwater tank based on the Tiger I Heavy tank. It would have weighed 60 tons, featured 80 millimeters armor, and been armed with an 88 millimeters gun modified to fire underwater. It would have crossed 2-kilometer wide rivers and stayed underwater for 2 hours. But the Schwimmpanzer VI never left the drawing board. Like its smaller cousin, it was a vision ahead of its time, a glimpse of what might have been if World War II had unfolded differently, or if technology had caught up to ambition. As the museum's lights dim at the end of the day, the Schwimmpanzer IV's turret casts a long shadow across the gallery floor. It is a shadow of innovation, of persistence, of a team of engineers who dare to build something no one had built before. Too advanced for its time, it failed as a weapon, but it succeeded as a testament to human creativity. In the end, that is its true legacy, not as a tool of war, but as a reminder that even the boldest ideas, when paired with patience and progress, can one day change the world.